Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about launch complexity. So let's dive deep into it. Now, what exactly is the need here? Well, rockets are loud. Let that be very clear. When I say this, there is no that is louder, like flat out, and it is so loud that it reaches from very loud sound to shock wave. It's bonkersly loud, and not to mention it's very dangerous. Now, small rockets not that big of a deal, but even a rocket that is quote unquote small, like Falcon 9, if it goes boom at fully loaded say, it will be a big kaboom. So let that be very clear. It's big and dangerous. And God help you if Saturn 5 ever went a boom or SLS went a boom and Starship. So fundamentally, this is something loud and it is very dangerous. Like it makes airport looks safe. So fundamentally, it does have certain requirement. Increasing cadence, that's the dream right now. Every Tom, Dick and Harry, be it SpaceX, be it Rocket Lab, be it ULA, be it Blue Origin, every Tom, Dick and Harry is like, we want more cadence. What does that mean? That simply wants to, they want to launch as many rockets as possible, as quickly as possible. So SpaceX is the champion and everybody else is the second position. Rocket Lab has reaching a point where they might be able to launch one per month. Blue Origin, let's see. But eventually, let's say by 2030s, people are planning to reach a point where one per day should be just like meh. So it does put a lot of strain on surrounding infrastructure. Before the modern era, as in like after 2020, this was not an issue. Like if you go in like, early 20, early 2000, nobody was even thinking about launching rocket that quickly. So surrounding infrastructure was like kind of built for that. Now with current scenario, like basically SpaceX could have done the modern launch cadence way long ago. It's just that infrastructure was not that good. So fundamentally we kind of overlook this, but you have to have a supporting infrastructure to sustain it. And there are a lot of vectors at play. You may not even think about this, like, oh, that's why we can't launch. So there are a lot of things that has to come into system, and it will become your limiting factor. Basically, how quickly can you transport your things, how quickly you put payload into it, because Starship launching right now is not that difficult. Why? Because there is no payload. The moment you put payload, again, let's just say if it's a lucky payload like a Starlink satellite, it can be shipped easily, it can be stacked easily and launched easily. But if it is a, let's say, space station module, whew, it's gonna be a big thing. How the heck you're gonna transport it there? How the heck you're gonna mount it there? All those things starts to make it difficult. So all of these things have to be taken care of, and crew and worker safety is paramount, because if this went off and somebody was there, yeah, they will be kaput, like poof. So fundamentally safety is very serious here, and not to mention many times you do national security things, so it's like, ooh, safety is like, yeah, it's non-negotiable. So let's understand the isolation part of it. This is the sound heat map that you can find for Boca Chica, basically how loud this is. And you can see like it's a huge area. Even though sound has what we call inverse square law, meaning it drops off very quickly. So at the center point, it's 130 decibel, and that's after the sound deluge system. But like you can see, it almost reaches other counties, so to say. It's loud, meaning very far away. Basically, if there was a jumbo jet going there, you will not hear it. If it's like it's a rocket launch, you will hear it, and you will hear it for a long time, because again, rocket launch is one of the loudest event known to man, second only by a nuke. So this puppy is very bonkersly loud, and it's continuous. That makes it worse. So that's why this basically heat map is huge, is because whoosh, it's not like a missile went kaput. It's like whoosh. So it's very, very loud. So generally you have to keep things at least 15 kilometers away to keep sound levels low as like 90 decibel. Now let that be clear. Can you build a structure that can handle this very close by? Of course, that's not a big issue. It's just that normal things are not designed to do that. And not to mention, humans are not designed to operate in an environment that is louder than that for very long duration. Yes, airport worker can keep, work and that, but they need shifts for this exact reason. And the airport building itself goes through a lot of layer of sound designing in order to make sure that it's not ear deafening, so to say. So fundamentally you have to keep things as far away as possible. And another aspect is you generally want to have ocean where you can go splash. Because first stage is one of the most naughty one. It's not fast enough to go into orbit, and nor it's fast enough to burn up into the atmosphere. So generally it lands with a full force, and it's huge. So unless you are China, where you can just drop it at your own people, it's like, who cares? Like, you can drop it in a school, even though it's loaded with freaking hypergolic propellant, which are toxic AF. So you can drop it in school because GG. But generally, even India is like, nah, bruh. USA is like, nah, bruh. This is like, no. So you generally want to splash this puppy into ocean. Spend stage, specifically booster rate stage. They are very brutal. And ideally, if you have a country to look for, you will try to go as close to equator as possible. So basically, equator gives you a yeet. So, and again, it's not the end of the day. Ideally, you will design a rocket that can go from anywhere. But if you can have an extra oomph that helps you in order to basically conserve fuel, which allows you to do better course correction at upper stage. So it's a dynamic thing. Of course, you will have margin, but having more margin is more better. So that's why isolation matters here. You want to have as far isolation as possible, because again, it is the loudest even after water deluge, and you have to make sure you have a splash zone where you can just splash without any issue, and ideally as close to equator as possible. India has some good, but there are certain unpopular country, but they have very good. They have an equator going through it, and they have clean sight, meaning they can just launch a rocket. It has sea, nothing else, perfectly from equator. India is like close. Sri Lanka has little bit of an edge on us, but not too much. But there are certain small countries that, if they ever developed a good space system, they're like, brah, we good. Their small rocket will be able to do some very heavy payloads because they are precisely at equator. Now let's understand the connection aspect of it. While you are going for isolated stuff, it's not just like, middle of nowhere. It has to be very, very well connected. Like if you will look into basically places how Russia is launching it, you're like, they have a very good infrastructure to go get there, be it railway network, be it airport nearby. They have to have all those things, because rocket needs a lot of things, not just the rocket, a lot of things that goes on auxiliary system, so to say. And payload specifically, or sometimes rocket itself, can come through road, air, or water. Now, America generally prefers water simply because roads are messy. They have a weight limitation and size limitation. So if you have a flyover going there, there's a size limit. If you ever wondered why the heck SpaceX rocket is so skinny, yeah, it was built by poor SpaceX. So that poor SpaceX designed the ability to ship through normal pathway. So they had a clearance issue. So they made the rocket skinny. While Starship is built by rich SpaceX. So they're like, GG. So again, you have to plan for it. So ULA, rich company, so they planned it via water barges. Again, it is expensive, and look into how much effort NASA had to spend in order to make sure they can move space shuttle from point A to point B. At one point, they are just like, yeah, put it on top of a jumbo jet and move it cheaper that way. So fundamentally, you have to figure out how the heck you're going to move everything. And again, it becomes a very complicated the moment you're talking about payloads. Not all payloads would be like, ship it anywhere. Like some payloads are so high sensitive, they are like very carefully moved, and they have a lot of buffer space. So even the payload size is not that big. They will have a environment control center that is like a huge block that is like completely controlled, weather sealed and all that jazz. You have to plan for all of it. And a lot of power are needed in that places. So it's not just like, oh, middle of nowhere, I'm going to build a small power plant. No. SpaceX also thought of that when Boca Chica was built. If you are following it for long ago, you would have remembered. They are like, hey, what if we put solar panels? Like, yeah, not good enough. Hey, what if we use this low pressure natural gas well? Yeah, not good enough. And eventually they had to circumvent and finally started to lay very high voltage. I think pretty sure it's a 33 kV or 133 kV lines they had to lay down in order to run the system. So same will go with all the launch sites. You would require a lot of power, and because it's a critical asset, you will generally do the same thing you do with servers. You will have dual link, meaning you'll have one main power station, another non-similar power station, meaning one would be hydropower dam, another would be coal power plant or nuclear. So you generally want to have that sort of redundancy. And water supply, because again, water deluge system do require a lot of water. So even though you're like, oh, this is just water tower, how we charge it up and then it discharges, cool, awesome, how the heck you charge it? And again, generally those water tower you see on space, basically NASA, they look small simply because the downcomer is too goddamn fat. But trust me, those tanks are humongous and they take a long time to charge. And that will become your limiting element. Just think of this way, like, we can the rocket, we got everything. It's just that, yeah, we are waiting for water. So water supply has to be matched to your Cadence requirement. Stable fuel and oxidizer supply. SpaceX is still messing up in this part, and I'm pretty sure it's simply because the power supply is not strong enough. They should have built by now air distillation plant, because again, that's the easiest way to get oxidizer. That's how everybody gets oxidizer. You just build an air distillation plant, stores it, done. And again, they also consume a lot of nitrogen, so it's like double whammy, and they can sell the argon. So stable fuel and oxidizer supply with long-term storage and range, sight, and security. This thing speaks expensive, because you are talking about multiple square kilometers have to be securely guarded, and it's not just like, oh lol, we just have a fence. Nah. You would require drones, you would require sentries, you will require basically cameras, CCTV, and armed guards, because again, many times you are dealing with national security things. It's not like oops. So you have to be very serious about these things, and these things are fragile. 150 caliber, kaput. So fundamentally, range, safety, and security is like, ooh, very serious. And not to mention, it expands to the water also, so you cannot just have a random boat or cruise ship going through there. Oh, and also air also. So it is very, and you have to have emergency system, because it is a boom device. It can go boom, so you cannot just like, oh, it went boom, let's just chill. No. You have to put out the fire, save the site as quickly as possible. So connections matter here, and you may have lot of worker coming in and coming out, so matters a lot. Now we come to the brain of it. So far, everything we are talking about is basically the bulk of it. But brain is basically Launch Control Center, CIC, so to sometimes they call it that. Basically, they have on-site big radio receivers, because you are talking about rocket, and it is the primary downlink until the payload deploys, and then they can use deep space network. But generally, this will have a very good on-site high gain antennas for radio receiver, and very powerful transmitter also, because again, inverse square law makes your life very difficult. You're like, okay, I have 1 megawatt of power. By the time it goes to the orbital rocket, it's like, eesh, barely enough. So fundamentally, you do need bonkers gain here. And link with local air traffic control, because again, they will be providing security, and sometimes they might have to reroute emergencies. For example, let's say if it's an air ambulance, they're like, hey, scrub the launch or something like that, or delay it. And if presidential planes flies by, yeah, that's like daddy. So you have to have a very good communication link, and I mean real-time link with local air traffic controller. High bandwidth downlinks. This is modern things. Back in the days, NASA used to build everything on site. Now they're like, yeah, we have spread it out. It's much cheaper. So, but you do need real-time links. Sometimes they are so sensitive. They're like, yeah, just lay a fiber directly from this site to that site in different state. Like literally one site, one fiber link. So you do need that. And payload specialists generally are off-site. So generally for that reason, you do need like a very good fiber links. And it also is working on with another concept where you have very good training. So all the data that primary command control is getting, it will be cloned into second place, and that second place would be for training. So that's a very realistic way of getting real-time training. So what can we expect in the future here? Well, fundamentally, we need a lot more things that are the limiting factor, not the rocket itself. So fundamentally, all those things, if everybody is dreaming, we want to do 1 launches per day, let's say Starship, Blue Origin, 1 per week. Yeah, you are talking bonkers amount of infrastructure that does not exist as of now. So SpaceX recently got approval of basically shift deleting ULA's old launch pad, simply because Launchpad have this one clause. You have to pay government for that license of that place, but you have to use it. You can't just like money and start up. No, because it's a limited resource, it has to be utilized. So they were not utilizing it. Basically the Delta rocket was kaput, so they're like, okay, we're gonna give this place to SpaceX, and SpaceX shift deleted it. Boomed it. So this whole structure, like, which is a giant building, they just shift deleted it. And what they are gonna plan here is basically second version of this. And to make sure that this time they can sustain it and don't have the stupidity of hundreds of trucks going there, on the paperwork that they are signed, they have planned for air separation for oxygen and nitrogen supply from day one. I'm pretty sure they have that on Boca Chica also. A lot of people are talking about it, and I've seen paperwork. It's just I'm pretty sure either they are stuck via power limitation or some government regulation. But it's silly to have that many trucks. And in terms of how the heck you're going to fuel the rocket, natural gas processing. And again, the same thing will be done by Blue Origin also. Because again, most rockets are switching to methane. So they're like, yeah, we're going to use that puppy. And because again, if you know about natural gas is majority CH4, but it's not 100% CH4. So to go from majority CH4, as in like 80% worst case scenario, to 99.99% CH4, you do need a processing plant that will be on site, and that puppy will create your pure high quality rocket grade CH4, and then that will be cryo frozen, and then ta-da. And in case of booster recovery, you will have the recovery hardware. And even Rocket Lab has to build a specific type of pad that is designed to handle some loud puppy. So that has to be built, and a lot more auxiliary system. Like to give you a context, if you watch the movie Apollo 8, which is like actual real-time footage of what happened, there were a lot of crew requirement in order to make sure that Apollo was always in ground contact. They had 3 crew, hundreds of people were cycled in one slot at a time. It's like, you are here from this shift, okay, shift A, you are working for 8 hours, cool, go home, go sleep, have your life. Crew B, do the same thing for 8 hours. Team C, do the same thing for 8 hours. Like, they had to cycle all of 3. So if you are doing that, you have to plan those things out. Like, will you have a railway link for there? Will you have on-site basically dormitories or things of this nature? Because again, if you want that sort of cadence, you have to plan those things. And again, you have to account for how the heck you're gonna vacate them in case of a rocket going kaboom. Or will it be far enough where if a rocket even does go boom, it's not an issue. You have to plan those things. We have not done that. Like, all these little things, they are like such information. It's like, once you actually build giant rockets, it's like, whoa, we did not plan for it. Like, this looks cool, and the fact that they are doing it so quickly looks cool, but you have to understand there is no payload. That's why it's so quick. So, and again, the moment they have to expand it, like really do 1 a week, yeah, that truck fleet will destroy the roads itself. So they have to fix it. They might also do the same thing with here, like natural gas processing, although that on-site well could provide it. I mean, it could be at least act as a, like, testing ground of technologies for natural gas processing. Again, it's a commercial system, but you still want to figure out who's the good supplier and all, like what is the conversion efficiency and all that. So a lot of things. Basically, expect this sort of plant coming up in Boca Chica and this place. So this was a presentation on basically launch complexities. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.